Hi guys. Previously, I evaluated this Piranesi, if that's how you pronounce it, GM328A component tester module, and I decided that it was useful enough to have it as part of my test equipment, and I therefore made an enclosure for it, designed it um, using Tinkercad, just to see what I can do with Tinkercad, and this is it here. So I have the display, the test socket, and I have an opening here for the SMD component area. And I found a little knob that I had to actually um, cut a little bit off to make it shorter, to make it fit, but it fits now fine. And some sockets for the external features that it also has. It has a volt meter, a frequency counter, and a signal generator. And I decided, rather than having separate outputs for these, I only have two sockets, and I decided to put a switch on that I can actually switch to the different modes if I want to use those modes. These, of course, have nothing whatsoever to do with the component tester, which works via this control and those two sockets on the display and stuff. Anyway, so now I have not finished wiring it up inside. I've just laid this out, and I've put it together to test for fit. I just thought I would insert this little piece of the video here about Tinkercad. In the following scenes in this video, you will find that I used Tinkercad in order to try to create this component tester enclosure. I was successful in making a version of it that works for me, but I found a bunch of problems with Tinkercad. Some bugs, like here, for instance, I wanted to move some of these holes around because I increased the size of the lid a little bit, and I ungrouped it. And instead of ungrouping it with holes, like there's one little hole there, all the holes became solids, and underneath there's stuff sticking out, and some of these holes, like these two here, one is slightly moved, and during the process while I was using Tinkercad, it lost a hole at one stage, and I had to recreate it. And I even got some problem, some internet connection uh, was lost, and it told me that it couldn't continue. I had to restart Tinkercad and so on. So at this point, I've used Tinkercad before for simple projects, as you will see when it closes this thing off. There we go. You see, I've got some um, little gizmos here, just simple stuff that worked okay. Anything from a pooper scooper to a little handle, some little miniature plugs, some lithium ion battery holders, stuff like that. It's simple. And Tinkercad is good for that, but for anything more complex, where you have to have exact measurements and things like that, the ruler only works when you look from top view and stuff like that. It just becomes too hard, which is much actually easier to do in something like Fusion 360. Here's um, a project box that I commonly use for my projects, which I designed. It has a snap-on lid, and let me kill the lid here so you can see inside. It has little notches there where the lid snaps in. It has little posts there for um, connecting the PC board and so on. And this works a lot better. So it was just an experiment. Tinkercad, the simple things, and Fusion 360 or FreeCAD even, or Onshape for more complex projects. I thought I would put this in the video so you'll understand what's happening later on, that I actually don't recommend doing it this way. Okay? And I made up a little paper template here that shows how things are going to be put together. Um, Obviously, the lid's going to have a hole for the display. There's going to be 4 holes to mount the PCB. It has holes there, which we'll use those standoffs for. It'll actually be mounted to the lid, not to the box itself, so the whole thing can slip down into the box. Got a hole here for that control. Of course, that knob will go on there, and there's a hole here for that test socket, and also there is a section here for SMD components that you can place on there to test as well. So it has to have a hole there to access that as well. So as I said, I made up this little template. I wrote up some sizes on there. What I'm going to do is put banana sockets. They're going to be like one here and one there. This device has little terminals on it, which I'm going to remove. I'm going to solder the wires directly on there, and all the grounds on these things, which is from the 3 sockets, are all connected together, so they can just be coming out. They can all be soldered to this ground socket, but the inputs and outputs and what have you, there's 3 of them. I don't particularly want to put sockets for each one on there, so I'm going to be using a switch, and I found in my supply a little 3-way switch, and which will be mounted over here. It won't stand up, but it's going to be a slot in there for that. And on the side of the box, instead of using there is actually a barrel connector, power connector on this thing here. I'm not planning to use that. There is another location here to solder power input wires to, and I'm going to use a separate little barrel connector that will actually be mounted in the box, side of the box instead, so I don't have to have a hole, and especially since I've decided to put the sockets over there because I wanted to have this clear on this side, and it would be in the way anyway, so I can now put this on the bottom of the box or wherever it might fit. Okay, so I've got the box completed, I hope, and I think. That's not what I want to do. So I've got the lid is red and the box is blue. I've got little holes and things. It would be a miracle if I got them all right. So what I'm going to do is I'm going to print just the lid and then see if it lines up on the board. And actually make the hit the T on the keyboard, it becomes transparent. You can actually zoom in and check that everything is there. I think everything looks good. Okay, so now we should be able to take the lid and move it off. I think I may see a little problem there. I think there's a gap between that. This is always something that can happen with Tinkercad. Okay, let's continue to move this off. Increase this to 1 millimeter so it goes a bit faster. And let's make this one transparent so we can see. I don't know. I think, well, let's turn it around anyway. Okay, so we've dropped it down because this is the way it's going to be printed on the. So I'm going to save this. And what I'm going to do is I'm going to duplicate. I'm going to delete the actual box. And what I'm going to do is I'm going to go to the top, and I'm going to take this, and I'm going to make a slice. Let's make it 95 by 95, a little bit bigger than the. And well, that's okay. So what we want to do now is to raise it by, let's say, a millimeter, 1 millimeter, please, there. And now I'm going to move that over the top, and I'm just going to leave a millimeter worth of the lid. And I'm going to print that out on the 3D printer and use that as a template and see if it fits or if I can move stuff around. Okay, so we just have a sliver here. I'm actually wondering if I can make it 0.5 millimeter. I think that would work. All right. Now we can export that to an STL file. We'll call that test box template, and we will put it in a Where's my drive D and stick it in the junk folder. Okay, it says completed, so okay, so I have loaded up the template in Cura, and this is how it's going to be printing it. I clicked print with Octoprint already, so it should be there. And there it is. So now I should be able to say print, load and print. Okay, so I've got my template. I've actually drew it on a piece of paper here, used it as a template because, and I've measured all the holes here, the actual sizes they ended up, and I'm going to go into Tinkercad and check. Some of these holes are too small and some need to be moved over a little bit. That's why we made this template, to make sure. This does not fit. It's 0.6 millimeters too small. It's 7 or 0.5. It's 7.5 millimeters, and it needs to be at least 8. Likewise, these little screws here. The hole is 1 millimeter, but the screws are actually how big are they? They're actually almost 2 millimeters, so that's quite a bit out. And if I mount this on here, the little window, it does fit, but I think I'd feel more comfortable if there was a little bit more height. And also this hole lines up nicely, and this hole will line up. But these two holes in this side, they need to be moved to the right about a millimeter. So that's what we're going to have to do in Tinkercad. See if we can. I think this one needs to go over a smidge. And this is the one we were working on. It didn't save that. Okay, we were deciding to give it some more clearance there. And then let me check the distance. export it as an STL file. Okay, here we are in Cura. I have loaded the STL file that we've generated. So let's have a look. Okay, a little bit better, not much maybe. Wonder what these blue things are. I think it's okay. Print with Octaprints. There we go. Okay. Here's Octaprint. And here it is. Load and print. Alright, things are being set up here. Keep camera in there. Autofocus, but it works. Okay, so I'm gonna dial out now for a bit because we don't want to sit here for 5 hours for that thing to print. Everything looks good there, so I'll be back when it's done. We can see if it fits. This is the final version here, and well, it's not actually the final version. This is an intermediate version as well. I still had to move these holes over a little bit. As you can see, I ground them out a little bit, but for my purpose, this is good enough. But as I said, I've updated the model in Tinkercad, so that should be completely correct. I have already mounted the switch. I put some stickers on there, and this little switch is mounted there. And you see, I had to make some raised. Here's some raised areas so that they would touch the PCB properly and not leave clearance for the display. So that is all working, and I've got two little tabs here, which once it's mounted would stop if you're doing a little SMD components. You have to push it down on the PCB, and I don't want those to fall inside of the case. So that's what the purpose of that is. I'm going to be removing these terminals here because I'm going to solder wires in there, and I'm going to be running the power supply in here, not in that barrel connector, and the ground on the power supply will go directly from the barrel connector to this ground banana socket, and then so I only have to run 3 wires from here to the switch. The switch is a little bit an unusual switch. It has 8 pins on it, and so because of that, it actually I made up this little diagram here. That's how it's going to be connected. When the switch is in position 1, those two terminals, because there's lots of them, are connected together. When it's in position 2, these two terminals are connected together, and when it's in position 3, those two terminals are connected together. But because we got 3 inputs that we want to get one output of, what we're going to do is we're going to take the output of this pin here and feed it into the opposite pin over there, and then the output of this pin and that pin is going to be the output to the red socket. And then what happens is, if it switches here, of course it'll go like this, or or like that. If it's in position 2, it will still, because that's the input there, it'll still come out of the same socket. And then when it's in position 3, it actually will connect these two pins together, and it will then still come out of the the third position there. Okay, so we're going to be using this bladed device, and we're going to try to heat both pins at the same time and apply a little bit of pressure underneath to remove these guys. There we go, see, easy. And I'm not sure if many people have shown how to use these things. You can get these kits here of desoldering tools. They're like little stainless steel tubes. They have different sizes, 0.8 millimeter, 1.2, and so on. And what you do is you heat up the little pad, and you actually poke the tool through it. You see, now we've got a nice little hole without having to mess around. So in that case, it is better to use the solder wick and wick off as much as you can, and then push this little tool through the hole, and we are in business. All right, so let's do the other ones. I'm going to turn it around. Yeah, these little guys, when I've been watching other videos, I don't see anyone using them, but again, you can buy these on AliExpress. I get all my stuff from AliExpress nowadays because everything's got so expensive, and they are the cheapest. Even Banggood, which is another, they are not cheap enough anymore. Okay, so let's have a look at this one. All right, I am going to put a little bit of leaded solder on there because there's a lower melting point. Now I've got some very old wick here. It is from my previous days in electronics, which is 40 years ago, and I'm determined to use it up, but it's a little bit corroded, so I have to put a little bit of flux on it actually to make it work. But waste not, want not, right? Make sure there's nothing on the other side. You'll find that this wick, as I said, on these double-sided boards are not able to remove all the solder. And as I said, that's where this little tool comes in. Actually, I wonder if I can use a slightly bigger one. Let me check. That size up. I want to put wires in there, and oh yeah, it takes the next bigger one, which is good. It'll clear out the hole even better. The stainless steel that they use, of course, doesn't the solder doesn't stick to it, which is the idea. Okay, next one. These bladed bits over here are great for that sort of thing. You can actually, little capacitors and things, you can heat up both pins at the same time, which makes it easy to remove through hole components like little capacitors and all sorts of things. Okay, that's the other one removed. Wick up the excess. Yeah, on this one I didn't put leaded solder, maybe we didn't need to. Okay, oops. Got the soldering station set to 350 so it heats up quick. But you have to be careful that you don't overheat these PCBs because the pads will come off. So you have to be quick. But that's another reason to use a little bit more temperature. There we go. Very good. Nicely done. Okay, so now I'm going to get some wire. Okay, so the first thing I'm going to do now is I'm going to apply a socket to this voltage input over here. It says plus 9 volts plus and minus. So what I've done is I've taken a little socket here. I buy these things in boxes, you know, from AliExpress again. I made one side red and the other side black to remind me where positive and negative is, because the little socket's going to cover that up. Going to be mounted like that. I don't want to solder wires directly onto the board for these for the power, so that I can actually remove the lid, because the other wires are going to be mounted onto the lid itself, so that's not a problem. But this one here, I want to be able to remove the device and from the bottom cabinet here, otherwise it would be stuck. Okay, so let's get some solder going here. I'm going to be crimping on this little connector onto a wire. We're going to be using just some scrap double wire here that I've got. I'm going to turn the temperature just down a little bit, because now we are soldering. 330 will do it, or maybe even less. Okay. I'm going to start off by putting just a little bit of solder onto the iron. Actually, I should probably switch irons. I don't want to use that big bladed one. Let me fix that up. Okay, I swapped out the big flat blade for just a normal tip here. Let's put a little bit of solder on there. It's always tricky to be able to hold these things down. So I just tack it on like that so it's not going to fall out. And then I will solder on the pins. That one's done. Now I can touch this one up. Okay, there we go. One socket. Let me see now if it's in properly. Yeah, it is now. Okay. So now we're going to have to see. Where's my wire here? Let's move this away. And we're going to need to put some these are teeny weeny little clips here. And we're going to be putting those on these wires. So first thing to do is find my snips. And what we actually want to achieve here, maybe I can zoom in a little bit. Okay, so what we want to achieve here is to put these things on this wire with those little legs here go onto the insulation, and this one here is supposed to grip the wire, and then this is supposed to get the pin inserted. So we only really need quite a short piece of wire there, like so. Just cleaning it off with a bit of isopropyl alcohol just in case. All right. So now we're going to get our pliers. These are my favorite pliers for that. I wish. What is it? IWS 3220M, and I use those for those little pins and sockets and things. So the way that they work is that they have different sizes. I don't think this one is marked, but this one I use for the I put a little arrow on there. I use that for those, what are those things called? You know, those little pins that you plug into breadboards and stuff. Alright, so I think that this one actually, so one thing that I do is I squeeze these little legs a little bit together. It makes them easier to get into the pliers. And if you look carefully at these types of pliers, let me see if I can change that. There we go. Oh, the size is on there, see? 1 millimeter, 1.3, 1.8, 1.9. And if you look carefully, you'll see that there is a difference. This is a bit bigger and wider than the one in the background. So the bigger, wider one is the one that takes the little legs that are actually going across the um, insulation. You have to orient them right. Yeah, I think that's about the right size. But what you need to look out for is that you don't squash the actual bit of the. You see over here there is a little tang that actually clips into the socket. That's what's the plug rather. And this bit here is what actually holds onto the pin on the socket. And in actual fact, I want to make sure I want a little bit more clearance there. Let's push it just a smidge. Yeah, now I am a little bit happier. You see, I've got a tiny bit of clearance there between the body of the pin there and the pliers. So now I should be able to plug in my wire. And to be honest, this wire is a little bit too big for those. No, I'm not going to use this wire. It is too thick. Chains of clam. Hold on for a second. Okay, I've just grabbed some of this nice silicone wire. I'm going to be using that instead of that old stiff stuff. And these I don't actually, this wire is fine, and I won't actually have to put solder on the end of it either to stop us from fraying. So I just insert this and make sure that the insulation is on this side. Now we can just squeeze it together and have a look. That is perfect. As you can see, these two little things are gripping the insulation, and these two are actually squeezing the wire. So this one is done. Now let's do the other one. Same deal. Squeeze these together a bit. Yeah, that's good. Here's the red wire. Make sure the insulation goes in there. Very good. This one also perfect. Now, just a little plug fell on the ground. Now, let's have a look. Now, this plug is going to be plugged in that direction. So, this side is going to be positive, and as you can see, there's little pocket holes in here, and that's where those little tangs on here go into that over there. And this is the positive side, so we need to put it in like that. And if it's in properly, we will see now that the little tang there, and you can't pull it out. It's caught on this little thing there on the in the hole. Same with this one. In it goes. Now, if you don't have the right pliers and you let us in and you put those little pins on there and you accidentally squeeze those little tangs, and you have to go in there and lift them up, sort of thing, to make sure that they catch. All right, so now we have our little lead here, which can plug into the circuit board. Solder it onto this. Oops. Okay, so now on these barrel connectors, we have a center pin and an outside pin. The outside is always ground. So we can actually solder this one on here. And the inside one is going to be positive. And that will go into here. So let's do the... I don't have this mounted yet, so I can move it around. Oh, you know what? On these, that metal that is like nickel plated or tin plated or something like that, it's always hard to solder. So a little bit of flux there will be really helpful. Otherwise, you'd have to heat it, and that takes a long time. There we go. That's one. Again, a tiny little bit of flux, less than a drop. A little bit went on the outside. I don't want it. Makes it sticky. Now what we're going to do is we're actually going to put some solder in here first. Like that. And we can put some solder on the actual wire. And then we can put it together. There we go. I hate it when that happens. One little piece of wire just sprung out of there. Anyway, now we're going to try to solder onto this thing here. I had to actually, again, this enclosure could have been a bit taller. This thing was hitting the bottom, so I actually broke off a little tang there, but I should be able to solder onto this stuff. It's all experimental, Here we go. So this one here, the voltage one, this is fresh, brand new wire, so I shouldn't need any flux other than what's in the solder. Okay, that one. And we can do some of these bottom ones. Now we're going to pick up one of these grounds over here. I think this one here looks like it's got a good fat trace going to it from all these grounds are connected together. That's better. Okay, that's done. And now, according to the specifications, the voltage measurement one is this one here. Actually, it even says so. See V for voltage. Oh, let me move it up a bit here. V for voltage. Strip the wire back just a weeny bit more. Yeah. Let's have a look. Voltage is green. Yes, correct. And then the other one is signal generator, square wave, whatever you want to call it, PWM. It only outputs square waves, not it. Something happened here. Doesn't output sine waves or anything like that. You never know. Might be useful for something. At least the pulse width modulation things. You could be testing a circuit for LEDs or something like that, that you have PWM on. and then you can actually test it. Okay, now we're going to strip the ends of the wires that we just connected. Okay, so we're actually done with the PCB, so we can remove it from the in here. So let me focus the cameras and stuff. Okay, so the first thing to do is to connect these two pins together and to this wire. Let's have a look if these holes are big enough for this wire. Yeah, they do. Some different wire strippers. Okay, so I'm following my little diagram that I made up here, and you see this is going to the red socket, and we've got these pins connected together. All right. Okay. Let me check on the other side there. Yeah, frequency is the middle one, so it goes over here. Come on, in you go, baby. Okay, this blue one then is the actual pulse width modulation, signal generator output, whatever you want to call it, and that is scheduled to go to that pin. No, one little piece of wire went outside, and you know how it goes. You solder it on and then it makes contact with the thing next to it and you got a error. Okay, that's better. Come on. Okay, this is screaming for some flux. When the solder gets heated and tired, it just doesn't want to dry up shiny anymore. So that's better. All right. Now, let's have a look. So the red socket should be connected to the green. Indeed. Yeah, all right. But not to red and not to blue. Okay. Next position of the switch is frequency. And frequency is coming from the top. That is actually the red one. Okay, so this switch was a bit dodgy, but I rewired it according to this little diagram here. It wasn't reliably making a contact between those two pins, so I put a little piece of wire across there, and I've tested that everything is working. So if it's set to voltage, V in comes through here, it goes across there, it goes here, and it can go there or there now, and it comes out to the socket. If we switch it to frequency, then this frequency in here connects like that, and it comes out here. And there's no connection here, but that doesn't matter, and there's no connection here, so it's not feeding back the voltage. Similarly, when we select the signal generator, square wave out thing. This comes in here, that would be connected, and it can go straight out here. And even though the signal would also appear here, there is no connection between any of those pins. So we are in business, and I've already tested that, so this will work fine. So now I'm going to put this thing back together. I have to put the screws and stuff in, so I won't bother doing that on the video here since that is kind of boring, so stand by. Alright, I've got it buttoned up here and connected together. I've got my little 9-volt wall wart here, and we've got to plug that in. Oh, just hold on for a sec. Okay, looks like I had to use a little adapter here. It was a slightly different size. Anyway, let's plug it in and see what happens. Okay, so there's power there. Let's grab a few little components just to see if it's working still. Here's a capacitor. Yes, sir. That's correct. 0.27 microfarads, 200 and something nanofarads. Transistor. To be yep, BNP. Okay, so I think all is working there. Now we want to have a look at the inputs here. So let's get some leads over here. 1, 2. We'll set to 12.5 volts. Let's do 12 volts. Okay, so now what we're going to do is hold this thing down, and we want to voltage. That's what we want. Okay, we've got 12 volts exactly. 12 volts exactly. Quite accurate, I think. So if I turn it up, 12.1, 12.2, 12.3. Yeah, it's following the power supply exactly. 9 volts. 9.09. Power supply says 9 volts, but close enough. Alright, so voltage is working. Now, Oh, function generator. Let's try that one first. Um, 250 kilohertz. Let's try that. Okay, 250 kilohertz. It says so over here. Square wave. 500 kilohertz. 1 megahertz. 2 megahertz. Now it says 1000 megahertz. It's 1 gigahertz. This little is obviously not what it is. Okay, 10 hertz, 50 hertz, 100 hertz. Anyway, it's working. So frequency. Let's select frequency. And I'm using this device here as a function generator. 123.45 kilohertz and oh, gotta switch the frequency, of course. Keep forgetting. Square wave. Anyway, it's all working. So I'm outputting 1.2345 kilohertz, and it says 1.3451 kilohertz, which is probably correct. Okay, so I think this is relatively successful little project now. Yep, there we go. Little component tester can go in the bin with the rest of them. Okay, so I guess we'll leave it at that, and we'll think up another project for next time. Any one of you got any questions, or you want to see anything, or any projects you would like me to look at, then please tell me in the comments. Goodbye.